subset is what we get when everything, well, we'd say something like this. A is a subset of B. First off, this idea of a subset, it has to be directional. One thing has to be a subset of something else. And so I'm using A and B as my stand-ins here. A is a subset of B, and this is the symbol we use for subset. What this means is that everything that's in A is in B. Every element of A is an element of B. This does not mean they're the same set, though. For instance, well, because it doesn't say that everything that's in B is in A. This is just saying that B is everything that A is, and possibly more. So if I said, if A is a subset of B, is it necessarily true that B is a subset of A? Well, I just exactly contradicted that. So let's say A is the elements 1, 2, 3. B could be the set 1, 2, 3, 4. In this instance, you can see A is a subset of B. Because everything that's in A, 1 is in A, 2 is in A, 3 is in A, all of those elements are in B. 1 is in B, 2 is in B, 3 is in B. Therefore, A is a subset of B. But B is not a subset of A. So I'm just doing the slash through, kind of like how we do with is not equal to. This means is not a subset of. B is not a subset of A because, well, while 1, 2, and 3 are in A, 4 is not in A. Could it be true that both A is a subset of B and B is a subset of A? Well, let's think of an example. How about if I compare A to, well, actually, let me do it this way. What about set C that contains elements 1, 2, 3? Is it true that A is a subset of C? Well, everything that's in A is in C. 1 is in A, 1 is in C. 2 is in A, 2 is in C. 3 is in A, 3 is in C. So that means A is a subset of C. How about is C a subset of A? Well, yeah, because they're the same thing. So actually, if this goes both ways, obviously I'm using C instead of B here. If it's true that A is a subset of C and C is a subset of A, then necessarily it's true that they would have to be equal to each other. Because everything that's in one is in the other, everything that's in the other is in the first. They contain all the same elements, therefore they are the same set. Okay, now let's talk about how many subsets we can pull out of something. If we have a set that looks like this, 7 and 8, it just has 2 elements in it, and we're trying to figure out how many subsets I could get out of this thing. Well, think about that for a second. Okay, well, there's 2 subsets that come to mind really easily, 7, 8. And, well, we were just talking about it. A set is its own, is a subset of itself, so we could go like that. But there's actually one additional set here. The empty set is also a subset of this B that I've written here. It turns out the empty set is a subset of everything. Because remember, the empty set is just a set with no elements. So if I say everything that's in this thing is in that, well, yeah, I guess all the nothing that's in here, you know, it's entirely contained within C, or, you know, C is it, but more. So the empty set is actually a subset of every single other set. So if we're talking about all the subsets of B, we can see there's 4 of them. How about of C? Well, this starts to get a little bit long. I'm going to go ahead and list this by the number of elements in each set. So there's only one set that has 0 elements. That would be the empty set. If we're talking about all the sets that have 1 element in them, we'd have a singleton 1, a 2, oops, a 3, a 4, or a 5. It's cumbersome to write these curly brackets all the time. If we're talking about sets with 2 elements in it, well, we could go 1, 2, we could go 1, 3, we could go 1, 4, we could go 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 3, or 4, 5. You can see this is already starting to get pretty long. So instead of approaching it this way, I'm actually going to erase that. Because, you know, this is starting to become a pretty long list, and I'm not sure exactly how long it'll end up being. Instead of going through and systematically listing each of them, what I'm going to do is I'm going to think of this from a standpoint of a bunch of yes or no questions. I'm going to say, okay, if I'm talking about a subset of C, then either it has each of these or it doesn't have each of these. And essentially, for each of those different ways I could answer a question, it's going to give me a different set. So, for instance, if I said the set that has 2, 3, 4, 5 versus the set that has 1, 2, 3, 4, 5, this would be two different sets. The only difference was whether or not one is contained. I could also say the same thing for, okay, what happens if 2 is or is not in the set? Well, for this one, I could go, well, let me just do it this way. It's a bunch of yes or no questions here. So first off, I'm going to say, is 1 in the set? Yes or no? This is going to lead to two different branches. Is 2 in the set? Yes or no? Well, this one up here is just if 1 was in the set. I can also do it down here, yes or no, down there. Okay, how about 3? Yes or no, yes or no, yes or no, yes or no. All right, how about 4? Yes or no, yes or no, yes or no, yes or no, and so on. How about 5? And again, we get a bunch more. But you can see, again, this is getting pretty long. Instead of trying to count them all up, let's look to see what's happening to the numbers. Each yes or no question has two different outcomes. I could say yes or no. For this one, there's two different outcomes. I had 2 different outcomes already. I doubled that, and I got 4 outcomes. For the third question, I would double it again. I would have 8 outcomes. For the fourth question, I would have 16 outcomes. For the fifth question, I would have 32 outcomes. 2 to the 5th. I'm asking 5 different individual questions, so this gives me 32 different subsets. So if we had a set with k elements, where we don't actually know how many elements there are, we're just calling it k, well, this is going to be 2 to the k subsets. If there are 10 elements, that would be 2 to the 10th. All right, proper subset, I'm just tacking this on here at the end of talking about subsets. Proper subset is, you know, we don't see proper subsets all that much. This is just what we get when we're talking about a subset, but we're not allowing for equality. So with subsets, a set would be a subset of itself. However, with proper subsets, that is no longer true. A set is no longer a proper subset of itself. We have to have that subset relationship, but we can't have equality. And so if I say, could it be true that A is a proper subset of B and B is a proper subset of A? Well, if everything that's in A is in B, and everything that's in B that is in A, oh, let me say it this way. Everything that's in A is in B according to this one, but B has to have something else. Everything that's in A has to be in B, but they can't be equal to each other because this says it's a proper subset. So if I flip this around and say, okay, well then, could it possibly be true that B is a proper subset of A? Well, no, it couldn't, because B would have to contain at least one element that's not in A in order for that proper subset relationship to exist.